Welcome to the part 2 series of ESP32-C5 microcontroller, which is a most powerful futuristic microcontroller. Rather than this iconic 5 GHz supported dual band Wi-Fi 6, it has BLE, Thread and Zigbee. Let's begin with the official product page from Espressif. One of the biggest highlights on the official website is the dual band Wi-Fi support and also the Thread and Zigbee support. When you scroll down, we can see the main features of the controller. The highlighted one, of course, that is 2.4 and 5 GHz dual band support with Wi-Fi 6 and other RF performance with the Thread, Zigbee and Bluetooth. ESP32-C5 and the room documentations are currently not available, but the document for ESP32-C5 dev kit is available, but it is in the preliminary stage. So this is our room development kit V1. You can see there are two USB-C port and room module is there, RGB LED. Now if you scroll down, we can see that schematic for the device. Next, let's configure the IDE. For ESP32 like devices, there are a lot of IDEs are available like Arduino IDE, Platform IO, ESP-IDF. I'm going to use ESP-IDF here because ESP32-C5 is newer in the market and hence Arduino IDE and Platform IO are currently does not support it. Anyways, it will be comes in the future, but ESP-IDF is the official supported IDE by Espressif itself. If you are new to ESP-IDF, refer my full installation video given in the description. Or if you want to do an update to the existing IDF version, continue watching. We are going to use the version 5.5. Let's start upgrading. Click on the ESP-IDF extension, expand the advanced, configure ESP-IDF extension so that it will pop up with a new window. Go to Express. I will be selecting the GitHub download server. I need to install the latest version, so that is 5.5 and just install. So the installation will take some time. After 30 minutes, the software will get installed. Next is programming. Open the VSCode. Once you open the VSCode, you will be getting this ESP-IDF welcome window, or else we can go to this advanced section in the extension part, new project wizard. Once you click on it, it will start creating the project. Since I am having multiple ESP-IDF versions, I have to select the version for which I am going to create the project. So the current latest version is 5.5. I will be selecting it. And if you are getting an error like this, which means we didn't open a folder for the VS Code. So first of all, let's open a folder for it. Now I opened the folder for the VS Code. Click on ESP-IDF extension. From this window, you can select a new project, or else in the advanced section, you can go for new project wizard. Check for the warnings and errors in the bottom section. So now new project window is opened. Let's give the project name. If you want to change the location of the project, you can change it. The target device you can change later also. So this version support with the ESP32-C5 selected. Now I didn't connected ESP32 to my laptop, so let's keep it like this. Now choose template. So first of all, I'm going to start with a blinking program. So in the template section, I will be going for ESP-IDF and blink. Create project using template blink. Now it is asking project ESP32-C5 first project. That is the project name which I have given. Has been created. Open project in a new window. Right now the VS Code is opened for the folder which we have created. Now it will shift to the project folder which we have created with this new project tab. So the welcome screen, if you want, you can just close it. This is our project tree. In this main, we can see a sample code for the blink _example main.c. When you install an extension, its supported status bar icons should be visible by default in the status bar. I have hidden them. Let's see how to enable these. Right click on the status bar and you can see the ESP-IDF related status bar icons. Let's turn it on one by one. So the build is created. Let me turn on everything and I will disable the other tools. Right now I am not using the remote host. Status bar configurations are not mandatory settings. These are small tips to keep VS Code visually clean. Now let's come back to the project. First thing is menu configuration. So click on this settings. So it will start creating the configuration editor. Menuconfig editor is open. We have opened this project for LED blink. All other configurations we will do later. This is example configuration part. So blink LED type. So before doing all those things, we have to know the development kit. We need to see the schematic for the development kit, and we need to find whether it is connected to GPIO, LED or LED strips. So let's open with the schematic. From this Expressive website, let's select the schematic. So we need to find the LED. Here we can see in the development kit, they have connected with a WS2812B single wire communicating RGB LED, and it is connected to pin number 27. Let's come back to the VSCode. So it is selected by default 27. If you want, we can change. And the LED strip backend peripheral will be using RMT itself, because RMT is capable of generating precise waveforms. So just save it. Now we can close the edit. The next thing is build the project. So we can simply build the project by clicking the settings icon, or else we can do this with single button, build, flash and monitor. To do that, we have to select the COM port for the ESP device. The device is already correct. Select the flash method. There are 3 methods. I am using the UART itself. COM port I have to select after connecting the device. Now let's connect the hardware. This is the module sent by Expressive. Comes with a good packing like this. Now let's open it. Share, connect, innovate. This is the ESP32-C5 module. Let's connect the hardware. Here you can see UART as well as USB. So we'll be connecting with the UART itself. This is the LED which is connected to GPIO number 27. It's also given there. Now let's upload the code. Click on this, everything together, build, flash and monitor. The process will take some time. While doing this build, flash and monitor, I forgot to select the COM port which is connected. So let's click on this COM port. So COM port 23, the build is completed. So now I need to flash and monitor. So anyways, I will click this single icon. So that it is keep on blinking. Also we can see the monitoring hours. This is LED set pixel. If you just expand this function, these are the parameters that we are using. The strip object, and second one is index. Since we are having only one LED, our index is 0. Next is RGB. Now I make only this 16, remaining these two 16 to 0, which means RGB. The green and blue become 0, so that we will be getting only the red color. So now only red is showing. Now if we change the red value, the 16 to the maximum in the sense, you can see here as a remark, when it is 0, we will be getting a 0% brightness. If you want a full brightness, then we have to give the 255. So I will change this 16 to 255 and re-upload. So we are getting the maximum red brightness. If you want to get a white full brightness, we have to give 255, 255, 255. Now if you want a green, let's make the red section to 0, green 255, then blue to 0. So the green LED. Now let's see about the programming. Since it is ESP-IDF, we are having an app main where our program is going to start. In this, first they were calling the function configure LED. So within this, we are selecting the blink GPIO pin, which we have already configured as 27, and the frequency also configuring here. We are working with RMT, which is capable of making a proper signaling on a GPIO pin. While configuring this LED strip, you can see strip config, which is a LED strip variable which we have created, basically a structure. Within this structure, we have to pass the GPIO pin number and the maximum LEDs that we are connecting, LED model. If you see here, we are passing only 2 parameters. Remaining 2 are they are taking by default. If you want to configure the model number WS2812, SK6812, WS2811. These are the supported LED modules, LED strips for the ESP32. And when you're configuring this LED strip for the RMT, we have to pass the strip configuration variable, second RMT configuration which is created for 10 MHz, and LED strip. This is nothing but the variable created for LED strip. Now come back to the main function, and now in the while one we are calling a function called blink LED. Here we are checking for a state variable which is nothing but created as a global one. Starting the variable state is 0, which is a unsigned integer 8-bit. So it is checking for the state and it is turning it on. And the second step, it will clear the LED strip. Let's create some sequence. Here the delay is called by VTAS delay. I will add a delay here itself for creating a RGB colors. A 500 milliseconds delay, and again LED. I will start with the red 255 0 0. Second time 0 255, and again. So for making little bit more attractive, I will remove this VTAS delay. These two are not required, but currently I will just comment it. Now again rebuild. So now I am missing with the delay for the blue LED. So let's add that as well. And that wraps up the intro video. Exciting projects like Deother, IoT, BLE and more are on the way. So stay tuned and don't miss out.